This show is supported by you. Stick around to the ad break to hear more. This is Cup of Go for May 3rd, 2024. Keep up to date with the important happenings in the Go community in about 15 minutes per week. I'm Shai Nechmad.
And I'm Jonathan Hall.
Hey, Jonathan.
Hey.
We took last week off, and now we just don't know how to do the show anymore.
Yeah.
It took us already 5 minutes to record the interview. So please forgive us if this episode's kind of all over the place. Actually, this week, most of our focus is going to be on security stuff. It just happened that this week is all about security, which is pretty cool. If you're into that, definitely stick around for our interview with Bartek Nowotarski. If you remember, we talked about the HTTP2 continuation flood vulnerability a few episodes ago, and we got the man himself on the podcast.
Yay.
So after the ad break, we're going to talk to him about like how he goes about researching vulnerabilities and stuff like that. But let's get into what's happening this week first, right?
Let's do it.
So open your calendars because the next 3 points are things that are going to happen in the future, unless you're listening to this episode way in the future. And then, I don't know. I don't retroactively add events to my calendar, but maybe you want to do that. First of all, May 7th, there's a minor release that just includes a private security fix. Should just mark May 7th on your calendar. Oh, I have to patch Go 122.3 and Go 0.21.10. So you're going to need to update that. We don't know what's the security fix yet. It's private for now. We'll know later. What else should I mark in my calendar? So May 7th, I updated my things. The CI built. And then May 8th, I'm shipping and like continuous integration, fixing all the bugs. I shipped. May 9th, what am I doing?
May 9th, you are going to Florianopolis, Brazil.
I imagine it with, with all the feathers.
Yes. You get to pay for your own ticket, but once you're there, you will be attending GopherCon Brazil on May 9 and 10.
I wonder if you're listening to the show and you're going to GopherCon Brazil, let us know. But at least for my money, it looks like there's a lot of really interesting talks. The language, like the titles of the talks are in, I think, Portuguese. I don't know if it's Spanish or Portuguese.
It should be Portuguese, I would imagine, if it's in Brazil. Yeah.
Yeah. I just see the word biblioteca and I watched Community, so I know it's Spanish-esque. So I think the conference itself is mostly going to be in Portuguese, if that's relevant to you. But the last talk is called Profile Guided Optimization. So maybe I'll just catch the last, plane to Brazil to listen to that. All right. So I'm done with Brazil. I'm feeling all good. Taking 2 weeks off, and then I'm May 25th. Where am I?
May 25th, you are flying to Taipei, Taiwan for Gopher Day Taiwan.
Gopher Day is so it's so much better than GopherCon. We really have to start adopting that other places as well.
I wonder if it is GopherCon, but just for a single day. If in GopherCon is supposed to be multiple days, I don't know.
Maybe it's a thing. One thing I can definitely say, it's the best Go related web thing I have seen. Like
the
it's
3D
not
flying
a
gopher?
web library. Just open. Even if you're not planning to be in Taipei on May 25th to go to this conference, which, by the way, looks like it's a really interesting agenda. Some of the talks have titles in English. Some of them have titles in, I think it's Chinese. At least my ad block seems to say that. But many of them are in English and they seem like super interesting. The one that caught my eye was PG Capture. CDC framework for Postgres. I didn't know it was possible to write stuff for Postgres in Go, but apparently you can write Postgres stuff in Go, which is super interesting if you have Postgres in your backend, which honestly you probably do. But the thing is, you need to go into that site and scroll a bit, and they have this like 3D gopher going through like portals, like the game. It's very good.
Now I want a Gopher portal game.
I just imagine the possibilities. So I'm traveling. I have May 9th, Brazil, and I have 25th, Taiwan.
Yeah.
I might not have tickets to these specific destinations, but if you're there or if you're interested enough, go attend. Going to GopherCons or Gopher Days or just conferences in general has been such a great benefit for me. specifically with Go, right? Because you can't really go to a conference about the thing you're working on at work right now, because usually it's hyper specific. And actually, other communities, at least in Israel, they were kind of worse. Like they're less consistent, they're less nice, they're more commercialized. But for Go, there's something. There's something in the conferences. There's something in the culture of the language that makes them really, really fun. So be on the lookout for that, and hopefully we'll let you know ahead of time. You can close your calendars now. Now open your Notes app, because 2 new blog posts have been published by Russ. They are all related to the same thing, which is secure randomness, basically, right?
Yes.
So I think it is worth separating this into 2 issues. One, let's talk about V2s in the standard library, without mentioning security at all. And then let's talk about security without mentioning the V2 thing at all. The first blog post is mostly about the fact that some parts of the Go standard are not great and they have to be evolved. They can't just be incrementally upgraded, but you have to introduce a V2 into the standard library, which is, I think, a very big step. What's the biggest drawback of adding all these improvements? Specifically, you're talking about MathRand, adding all these improvements under a new import path, MathRand V2, versus just upgrading them internally. The blog post goes into this in detail, but I think it's worth highlighting like the obvious problem with introducing this new V2 library, right?
Yeah, I mean, I think the biggest problem is that not everybody's going to know that it's even there, and they're going to keep using the old one, or they'll keep using the old one. But yeah, just by default, they'll keep using the old one. And then if they choose to upgrade, it's not a clean upgrade path. Like it's breaking changes. That's why it's a V2. So you actually have to think about upgrading. You can't just like change your import path in most cases. You have to actually make changes to your code.
So the reason, obviously that makes it sound like, so why introduce a V2 into the standard library? Like if you're maintaining your own like third-party lib and you decide to version your library one way or another, that's like your own thing. But when you're maintaining the language, seems like you wouldn't want to do that. But in this case, because of the underlying responsibility of this library, which is generating pseudo-random numbers and being deterministic about it, if they upgrade the underlying implementation, they will break existing code, which breaks the compatibility promise. But the problems in the underlying library were so serious. They used, a bad number generator. And the blog post goes into detail. The second blog post goes into detail about the new generator and why it's good. But it's not optimized. It doesn't scale well. The interface is kind of weird. I don't know if you remember, but it's int 63. Whenever I saw that, I was like, wait, am I doing something wrong? Why am I working 63? I thought it was 64. Like it's very confusing. And there's a mistake in the interface as well. It's not just like the underlying implementation is bad. They didn't want people to use MathRand for security-related things because it's not good for security-related things. MathRand is seeded with a small number, and therefore the entropy is low by definition. All these things combined, they could fix some of them directly in MathRand, like automatically seeding the generator and trying to adapt some better generators and marking it as deprecated and stuff like that. But they couldn't really fix the whole thing in the MathRand. So they had to release V2.
Yeah.
This blog post goes into detail about how would you involve Go standard library. Again, in your own libraries, do whatever you want and whatever is comfortable and whatever feels good. But if you have 2 million Go developers using your quote-unquote library, which is basically what the Go team is in charge of, they have to take these considerations a bit more seriously. And their sort of direction for the future is not, we're going to do V2 for all the libraries today, and you can expect all Go code in the future to have a big stinking V2 at the end. It's quite the opposite. They're saying we're not going to go with the V2 unless a really high bar is crossed. Like all changes must be related to existing things. Like we won't introduce things in V2 that look good, but are not, our users are not shouting at us. And you mentioned about the upgrade path, right? They want the upgrade to be as smooth as possible. Obviously, it's not automatic because they changed the import path, and it might break stuff for you, which is why you need the V2 in the first place. But they want the V2 to be very close to V1, so it's very, very easy to upgrade. They just want you to avoid work if you want to go into V2.
Mm-hmm.
So super interesting direction for the language to evolve in. On the one hand, I'm feeling that's great that they fix stuff and they're not stuck because of backward compatibility promises. This is not like most code can afford to upgrade, and that's great. On the other hand, I don't know, V2 in the standard library and 2 different import paths for Rand just feel very icky. All the content that's ever been written and all the AI, training on Rand, like if you probably if you ask AI to implement a random number in Go right now, it will go with the old implementation, right?
Mm-hmm.
Not the new one, because it hasn't been trained yet. And that's true for, people looking online, how to generate a random number in Go. I don't know how I would have resolved it differently, but I definitely feel a bit uncomfortable with the V2 versions in the standard library.
Yeah. Yeah, I can see that. I'm not sure how I feel about it either. I can definitely sympathize with the decision to not break the old API, in subtle ways. Like we could implement those changes without changing the API, but it would break the behavior, which is part of the API too, right? So yeah, I can sympathize with that. I think V2 is the only option that was left open, given the backward compatibility promise.
Mm-hmm.
But I agree. It feels a little bit less than perfect, which I suppose is why this is the only one so far.
Although JSON V2 is also on the horizon.
Probably on the way, yeah.
So this is about, this was about if we want to upgrade any library, like MathRand or JSON or whatever standard library we'll need to upgrade in the future in the way that's breaking, that's how we're going to do it in the future. I think this is really well communicated. The Go team doesn't get enough, cred for their communication, but this is really well written. It's super well explained. And the reason you feel sympathy for this decision, like, what the fuck, what are they doing, is because it's very well explained, in my opinion. Yeah. It doesn't come from any place of, we decided to unidirectionally. It really feels like you're walking through the research with them. Let's talk about the interior, not the exterior of this issue. What was upgraded? What are we generating? I thought random numbers, you just roll dice and return 4.
Just return 37. That's all you need to do, right? Yeah. So the second installation of this, I guess you could call it the series, talks about the implementation they chose, and then more importantly, the background and how they chose the implementation. They talk about the old implementation and how it was done, and the new implementation, how it's done. And the TLDR is there's been a lot of research into pseudo-random number generators in the last 2 decades. And we know a lot more now as a human race. We know a lot more about how to efficiently and securely create pseudo-random numbers than we did even 10 years ago. So the new version just uses newer algorithms that didn't exist back then, or a newer algorithm, I should say. It's much more efficient in terms of memory usage. I think they said it takes a little bit more computation, but it uses much less memory, and it's much less predictable, which is the most important thing of those 3.
Yeah, it makes you more secure if you accidentally use MathRand to generate, let's say, a key, which you shouldn't. You should use CryptoRand. But if you accidentally did do that, which is a very reasonable mistake to make, now you're a lot more secure. I also really like the name, Cha-Cha-8 Rand generator. Is very catchy. There's a dive into performance here, which I really like. Whenever a blog post includes gratuitous benchmarks, right? And there are interesting comparisons here. What stands out to me the most? I know I shouldn't highlight that because the thing here is the algorithm. It's just how much the M3 Apple is a beast compared to other machines on here. This week, I don't know if you saw it, but it's not in Go news. It's in Ruby news. Ruby on Rails guy, DHH, just released another inflammatory blog post saying we're not even going to do CI on the cloud anymore. We're just doing it on developer machines because the developer machines are so strong. And I read, and just like you reacted now, I rolled. But I don't know, man. The new M3 Max is a beast. It's very, very, very strong.
Anything DHH says makes my eyes roll.
Yeah, for sure. But you know what? He's writing content on the internet. That's good enough for me. And it's not hate speech. That's good enough for me.
Sometimes it is.
Cloud hate. That's okay-ish. Anyway, so there's another blog post co-written by Russ and Filippo, which we hosted on the show, about the secure randomness in Go 122 and basically the reason why we needed the V2 rand in the first place. So if you're interested in the more technical details of generating secure numbers, generating random numbers securely, I should mean, the most secure number is 0, obviously. You can go read this blog post. So a good pair, if you're more into like language management, the human part of managing a language, you can read the, evolving the Go standard. And if you're more into the bits and bytes, you can read the secure randomness in Go blog post. A really good selection this week.
But wait, there's more.
Ooh.
We're not done talking about random numbers yet.
All right, I'll start. 3, 7, 7, 5, 7.
Those are just prime numbers. Of course, everybody knows a good random number is also prime.
Yeah, for sure. The thing about random, people don't actually want random. This is an unrelated rant. We had friends over this week, and we played this Switch game. I don't remember what it's called. Unspottable. It's actually pretty good. You walk around and you try to you punch one another, and everybody looks the same, so it's funny. And they have a random level selector. And I think they implemented it with true random, not like Spotify Shuffle. And then we ended up playing the same level 4 times. And everybody was so angry. And I was like, this is what you wanted. You said random, and this is what you're getting. People don't actually want random. They usually want shuffle. The unrelated. What's the new proposal about?
So the new proposal is, this doesn't sound like it's related to random, but hang in there. We'll see. We'll see how it ties in. The new proposal is to require Linux kernel 3.17 for Go 1.24. Now, keep in mind, we're on 1.22 now. 1.23 comes out soon. Oh, by the way, a little side note to that last, the first blog post, the little summary that shows up if you share it on an RSS feed or something, says Go 1.23, but it's actually Go 1.22. So there's a typo in that little thing.
Oh.
We're still on 122 as we heard about the pre-release announcement coming up on Tuesday. So still 122. The proposal is for 124. So in 2 major versions.
To make 2 major versions in Go means 1 year, right?
Essentially, yes. Yeah. So a year from now, or almost a year from now. So yes, about a year from now to make Linux kernel 3.17 the minimum for Go. Right now, the minimum is 2.6.32, which was last updated with Go 1.18.
When is Linux kernel 3.17 from? How much, does that mean that Go is only going to work on super modern machines?
It's old. I mean, the version 6 point something is out now. I don't remember. And I don't know how quickly they come out. It is old, but somebody did a nice little summary here for comparing kernel versions to distribution versions. But before I get into that, I want to mention something else that Filippo, our friend who helped co-author the last blog post you mentioned, that if we would go to 3.17 rather than 3.2 was the original proposal. Okay. He says if we go to 3.17, then we can drop support for the old Linux kernel random number generator. So the proposal updated to let's make 3.17 the most recent, or the oldest supported Linux kernel. And that leads to this comment where somebody looked at Debian 10, which uses kernel 4.19. I think they were looking at the oldest distribution that's still supported from each major distribution vendor is what they're looking at. Ubuntu 20.4 has kernel 5.4. CentOS 7 has kernel 3.10. Oops. And CentOS is available for long-term support until 2028. So if you buy support from them, which Google, by the way, sells in the G Cloud, you would be, this would put this Google in a situation where they're selling operating systems that can't run modern Go. Somebody did some digging and found that the Red Hat Enterprise Linux 7 kernel that is used, 3.10, has a patch to backport the get random syscall. So the new proposal is you need Linux kernel version 3.17 or version 3.10 plus get random backported to use Go 1.24.
I think, the cost of maintaining these old kernels in the Go project is pretty big. I would assume that if I were to try and run Go 122 on Linux 2, like kernel 2, I don't know, I think it's Ubuntu 12 or something like that, I would just assume it wouldn't work, honestly. Something would mess up. And, even if the standard library sort of works, the moment I try to introduce new libraries that don't have all these advanced testing mechanisms in place, nothing would work. Like I wouldn't be able to import new libraries. I wouldn't be able to use new stuff. What I'm saying is it makes sense to me to upgrade, but I really wouldn't want to be in the place where I'm maintaining for some reason or another in a company, I'm maintaining a server that cannot be upgraded, right? Because it relies on something that gets broken in a newer Linux kernel version. I imagine some like bank software or like these sorts of things. And I want to use Go and I can't because it dropped support on my hardware. Again, 3.2 is 12 years old, which in software terms is almost ancient. But on the other hand, there is something I really like about Go where it's just compiles and works. So I guess you're not really limited from using Go. You're just limited from using newer versions of Go. The problem there is that Go only has support for 1 year, right?
Yeah.
What does that mean? Your compatibility promise in Go goes 2 major versions back. Like we just said, it's 6 months and 6 months. So you have a 1 year window to catch up to one of the latest 2 versions. And then you're stuck with security vulnerabilities and issues because they just don't get upgraded. I don't know if there's a better way to balance this out, because this basically means if you have Go software that you wrote and you want it to stay up to date, at least once a year, you have to go and upgrade it, right? Because you want it to stay on the latest version. But at least 1 in 10 years, it means you have to upgrade all your servers and your Linux kernels and whatever. I usually don't think about software in those timescales, right? A decade. But maybe we should.
I think it would be nice if somebody, maybe a third party, would provide security backports to old versions of Go. Maybe not every old version, but maybe every other or every 4th version. So if you're stuck on Go 1.17, you can at least have security updates for a while.
Yeah, but if the patch uses a newer feature, right? Let's say the patch uses generics, you're out of luck.
Well, then you have to write. Then this third party would have to write a non-generic version of that security.
I'm seeing what actually rewrite it in Go 1.17.
Kind of like Ubuntu and Red Hat do. I think it's every other version or certain versions, at least every 2 years, a version has a long-term support. I'd like to see an LTS version of Go, every 2 years or something.
That makes sense, but I someone has to have the financial incentive to do that, because most of the companies running Go run them on the cloud. They don't run them on old mainframes that have Linux kernel 1.
So if you need an LTS version of Linux, hit me up. If we find enough demand for it, I'll do it.
For sure. That sounds very relaxing. Just rewriting.
I just backport security patches to Go in my spare time. That's all I do.
It sounds like something you could busk on the street. You have like one guy doing this shitty graffiti art, of like a moon over with the spray can. One guy writing code. Like I can imagine the clickbait title already. You won't imagine this old time classic developer backporting security patches to Linux too without GitHub Copilot and without generics. Must watch. Wait until the end. Heart emoji.
All right. I love it. We have to do that. I think we're done.
Yeah,
I think we made it through our list.
This episode, but definitely stick around for our interview with Bartek. It was super interesting. And yeah, no break next week. We're back on that grindstone. We'll talk to you next week. Bye. This show is supported by you. You can support us directly by joining our Patreon, link in the show notes, to contribute $8 monthly to help us cover editing fees, hosting fees, and just, for our time. This is a hobby. We do it for fun. We do it for the community, but it's also kind of expensive. We really appreciate all of our current members. Thanks a lot. It really validates the work we're doing here, and the work we're doing here is fun. So thank you. We also don't pay to advertise this show. So another way you could support us is by spreading the word, tweeting about the show, posting about your favorite episode on the subreddit, talking about it in other Golang communities, physical and or virtual, or sharing this episode maybe with someone at work who's trying to get into Go and looking for a pair of friendly voices to ramble, let's say 50 to 60% about the language, and just sort of 2 guys on a podcast at the next 50%.
It's your Go morning show.
Yeah, for sure. It's Shay and John on the morning. KTPLM. If you want to reach us, cupogo.dev, https://cupogo.dev. That's our site. You can find all of the links there, including links to our Slack channel, #cupogo, uppercase with hyphens. Our email, news@cupogo.dev. That is news@cupogo.dev. You can also find our swag store where you can buy cups and wireless chargers and hoodies and shirts and stickers. And yeah, thanks a lot. We are energized after our brief break. There's a lot of Go new stuff we left in the backlog for next week. We're actually at the point where some tickets are like Spartan children, where we leave them out in the backlog and they don't come back. So they're not worthy for the show because we just can't prioritize them for episodes. And I just wanted to thank all the people on our Slack channel. I had some interesting conversations, even though we didn't have an episode. First of all, we have to say a huge shout out again to Yanik. Through our Slack channel, he connected us to Bartek, who's joining the episode today. And, there are some interesting conversation going on there. Jonathan is posting some brain teaser questions, which I could imagine people using in an interview. Like, you've decided you need an ordered map. Do you build your own or use a third-party library? And why? Sounds like good interview prep. I don't know if we're actually helping you pass coding interviews.
No, I was trying to solve an actual problem.
Actual problems? I don't know what you're talking about.
I know.
And, talking about old episodes. For example, we talked about episode 30 where we talked about Open Tofu. So apparently HashiCorp got bought by IBM. So there's a lot of like after party vibes going on in the channel. Totally. So I really wanted to thank the channel for these vibes. And also feel free to post and join and shoot shit. It's a lot of fun. That's it for our ad break this week. And I'll just let you get straight into the interview.
Audio.
Bye-bye. Jonathan, have you seen the message from Yanik on Slack?
Did. Yeah.
So we asked people to connect us to Bartek about you remember that guy who did the HTTP flood vulnerability we talked about?
Yeah.
Apparently, there's just an email at the bottom of his page. But we did the long way around, and Yanik sent an email for us. Thanks a lot, Yanik Hubner from disroot.org. We really appreciate you connecting us to Bartek. Hi, Bartek. Welcome on the show.
Hi. Nice to meet everyone. And thanks for having me here.
This was sort of a Rube Goldberg machine, I imagine. Like me sending the Slack message, a ball falls, the hamster starts to run, the fan turns on, the broom falls down the stairs, ping pong ball, tak, tak, tak. Eventually, Bartek joined. We could just have emailed you. But, if it's stupid and it works, it ain't stupid. So, Bartek, welcome on the show. How about you introduce yourself to people who don't know you?
Sure. A quick intro would be, my name is Bartek, and Shai, basically your pronunciation of my name on the episode about continuous flood was perfect. So congrats.
Jonathan, you want to give it a try as well? Putting you on the spot.
No, it's actually, it's kind of complicated actually. It's a long surname. So, but currently I'm doing security research on my own. As you mentioned, last month, my research about the continuous flood was published. So I guess we'll talk about it today. In the past, I worked at star.org. I was a staff software engineer. We can also talk about it if you're interested. And before then, I was running some startups, which mostly failed, and also doing some security research when I was a bit younger. So yeah,
that's very cool. Is your current work in security research just focused on Go, or just focused on networking, or like all over the place, whatever?
Sure. So maybe this answer will be a little bit longer, so you can have a quick, reasoning behind what I'm doing. So as I mentioned, like in the past, I was working for a company called star.org, which is doing like financial services for underbanked. Basically, it's like a network of gateways, anchors around the world that can join the open network and send money. I spent there 8 years, but over this time I got interested in security. And actually, instead of like saying I got interested, I should say I returned to being interested in security. I was part of the Stellar Org internal security team. We were like, because our stuff is public, open source, we got a ton of attacks. So it was pretty challenging there. And basically, after 8 years at a single project, you kind of like, you usually try to, maybe search for something else because it was actually quite a long of time. And also I think at the time I was thinking like, my job here is done. So I was behind a pretty large project called Horizon. And it kind of like became mature enough, so I thought I could leave. But the real trigger to leave was a war in Ukraine. If you know, like I'm from Poland, and it has a long border with Ukraine. And I was like, okay, maybe I should switch to security to be useful somehow if the conflict actually expands my country. So I gave a heads up to my manager at Stellar like half a year before leaving, right? And in the beginning of 2023, I left. So I was lucky enough to have a short vacation after that. And I was thinking like what to do next. So I had like two options. First option was like starting sending resumes to different companies. But I was thinking that, my experience at cybersecurity is not big enough to actually be hired at the non-junior position, I guess. So I was like, okay, maybe I should spend a few months actually trying to do some research on my own, like learn stuff and then apply, right? So actually I started doing this, and this is actually, I can actually start answering your question. So at first I was doing research in Golang. So over the second part of 23, I found like 3 vulnerabilities in standard library of Golang. Maybe I can skip details if you're interested. I can share more. And I was pretty liking it actually. And also like discussions with security team of Golang were pretty nice. I learned a ton from them. Also, so I decided like maybe I should stick to that. And also when I started doing Golang research, I didn't know they had bug bounty program actually, right? I was doing this just for myself and to gain some experience. But like in the last quarter, I think of 23, I realized that Google has something like Google vulnerability reward program. I can earn some money on these bugs, right? So I was like quite lucky. And by then I decided that, maybe for now I will stick to this, right? And in the beginning of 24, actually, as I mentioned in my blog post, I decided to do some research around HTTP2 because I knew about rapid resets, right? Which happens in Q2 of 23. And basically what I started to do was checking like how Golang implements this, right? Actually, it's very interesting because they have this external x/net/HTTP package, which implements HTTP2 package, which implements it. And what happens on the, I guess, build time of Golang itself is that they actually bundle this external package as an internal bundle of standard net HTTP package, right?
So I think the X libraries are sort of a limbo, right, Jonathan? They're not really standard, but they like should be the standard of the future, something like that. That's like what the X
sometimes
means.
there's a sort of a grab bag there. Some of them are treated as though they're standard libraries, some are not. I think the main thing is they don't have the same release cadence as the standard library.
So I definitely treat them as standard. Like if I see something imported from X, I'm like, oh, it's good, no problem. Solid is gold, but apparently gold is not so solid because you can bite into it. So maybe it's
gold is still soft.
An apt analogy actually. So the HTTPX library is compiled into Go like as an internal library. That's what you're saying.
Exactly. I mean, there's probably some script that basically for all of the files in this package, they build like a single file. I think the name is something like h2bundle.go. And actually what I did, I started analyzing this file, and then actually I switched to this external package, right? Because it was much easier to read because there were like separate files and stuff like that. And also I was reading the RFC, right? Because like the code was the standard for me, right? I was reading the code, but when I when I wanted to clarify something or understand something better, I switched to RFC, to like this part, right, of the protocol. And yeah, actually, maybe I was lucky, but very quickly I noticed this pattern in connected to continuation flag, right? Because it seemed to me that there was a bug. I don't know if you actually saw the commit that's fixing this bug, but the problem there was that there were like two different parts when actually three different parts of where continuation frames are parsed, right? So the first one is something that's called meta frame, and meta frame in Golang. And actually later on, I also realized that this pattern is very common in other languages. So meta frame is kind of like the bundle of headers frame and continuation frames connected to this header frame, right? So basically, instead of like they can kind of like encapsulate entire header stream into this meta frame, which contains all of the frames, right? So this is like the first place. The second place was actually the for loop that reads frames from this meta frame, right? And the last one was actually the callback of the HBAC decoder that, triggers on each new header from these meta frames. So because of this kind of like separation of concerns, I think the programmer who wrote these codes missed that, because the logic behind like the limits of headers, right? Because, usually HTTP servers have the limits of headers, basically to prevent such bugs, right? So the logic behind this was like in the callback, right, of HBAC. And it actually, there was actually like a variable that says, okay, if you reach the limit, stop processing new headers. But the for loop that was actually reading headers from meta frame was still going on until the end stream or end headers flag was set, right? Mm-hmm. So this was the bug in Golang, and from the range of bugs across like different servers, applications, and languages, this was kind of the on the lower end of severity, right? Because it didn't fill memory, which would lead to a crash of the server, but instead it consumed CPU cycles, because it had to process all of these headers until the attacker stopped sending headers, which basically can never happen. Right?
So it can cause denial of service, but not necessarily through crashing the server, but just by grabbing enough CPU time. But if your server is set up correctly, for example, you have different thread pools for different IPs and stuff like that, then not all clients might be affected. But on the other end, like, severity might be low because it's not causing a crash, but I think it might be like it's worth considering that it should be higher, because you only need one machine to run this attack versus a distributed, you don't need something very complicated to set up this attack. Like, you can run it from 1-2 machines, and it's probably going to be enough to completely block most of the Go servers.
Yeah, so that's actually not true. I can maybe a little bit expand this, right? So this one machine case is valid when we actually try to exploit this out of memory, right? Because then if the server actually, like, for each request, it basically concatenates headers, then it's true, you need just one machine, right, to crash the server, because eventually the memory will fill up and the OS will kill the process. But in the CPU case, actually, it's possible that you can kind of like make the server unresponsive, but usually it would require more connections, right? Mm. Maybe not a botnet, right? But maybe a few thousand connections, which is actually, it's probably possible from a single machine, actually. So maybe that's true, but it's not that easy as out of the memory. And also it depends on the implementation, right? Because some implementations are faster, some are slower. So it's really variable, I would say. But basically the most severe cases were out of the memory crashes, right? Because then you're kind of like guaranteed to crash a server with a single HTTP connection.
I'm curious to understand. So I want to clarify. I think you said that you're doing security research now on your own. You're independent. Is that correct? You're not working for a company?
Yeah, that's true. So I'm not working for any company. Maybe I will join a company if I find some interesting projects, and they will actually also want me to join, right? But right now I'm kind of like not actively searching.
So how are you? I mean, is the Google's bug bounty the only way you're getting paid right now, or what does your income look like?
Yeah, sure. So that's a good question. So so Google bug bounty is not the only source. It's not the only bug bounty, right? So if you check the servers affected by continuation floods, it was actually a ton of them. I was lucky with that one because I could basically send this bug to other bug bounties for free. So basically, Node.js has their bug bounty, Apache has their bug bounty, right? So it was nice. But I'm also doing some private bug bounties which I don't publish, right? To answer your question, Google's VRP is not the only one.
Okay, I guess I don't know if you're willing to share this. It's probably public information anyway. But how much does a public bug bounty pay? How much would Google pay to discover an HTTP2 bug, just for example?
Yeah, so actually for Google, I'm not sure, to be honest, if it's public. So maybe I won't share that.
Yeah.
But I can say one thing. So I mentioned that I found several CVs last year, right? So actually DOS bugs are on the lower end of pay scale, let's say.
Mm-hmm.
I found an interesting bug in host header processing. In Golang actually. So the bug was if you were if I as an attacker, right? If I were able to somehow change the host header of the client sending the request to HTTP server, I could actually inject another request, right? So it was possible to do some unauthorized requests. So this one, which personally I didn't think was actually severe to me, because the requirements to actually trigger this bug were pretty complicated. I got more money from this one rather compared to continuation flood, right? So this is for Google, and for other bug bounties I can actually share because this is public, and you can actually find me on hackerone.com, which actually lists my findings and also the bounties. So for bug bounties other than Google, this bug paid me something between $3,000 to $5,000 per project. But Google paid less. That's
okay.
I think just to put it in context, over 2023, Google paid out around $10 million in bug bounties. Not to Bartek specifically. Otherwise, we would probably having this conversation from his yacht or something and not his shared office. But just overall, to all security research. So $10 million sounds like a large amount of money, but when you consider the breadth of how much software Google has and how much attack surface it has, it actually is very reasonable, I would say. I don't think it's cheap, but it is very reasonable. But I just want to give this context because this is an interesting comparison. Bug bounties is the good way to go, right? You find a bug and you report it to help the community, and the company pays you because you helped everyone be more secure and everybody's happy and great. The actual worth of a bug is a lot easier to see when you look at exploit acquisition platforms. How much people are willing to pay to exploit the bug and not just to patch the bug. Because patching the bug comes with, when someone reports, you actually have to fix it if you want to, as a company, as Google, they have to fix it because they want to stay compliant to all this sort of stuff, right? But the actual worth of worth of the exploit itself, you can find it in. I don't even want to promote these platforms, but there are platforms where you can buy, where you can sell all these exploits, right?
Upwork for black hat hackers type of.
It's exactly that. It's you sell your 0 days of vulnerabilities, and they have their base. For example, Windows remote code execution 0 click is $1 million to start with, and that's the top of the range. And then if you have a remote code execution on routers that requires click, then it's only $10K. So there's very.
I see you're very familiar with these, Shai.
Yeah.
I'm a security
nerd.
Yeah. Sorry, just a quick note from me. So I think because you mentioned Google paid 10 million, right?
Overall to everyone.
Yeah, exactly. So yeah, I wanted to exactly resonate with you. So, there are bugs which pay even $1 million, right? So it's possible that there are like 5, hackers that earn like 50% of this, right? So yeah, it really depends on severity, right? And for Google, Cloudflare, DOS, and I think that's actually reasonable, is very, on the very low end because they have like tons of servers, and I guess, it's very hard to DOS them anyway. So
there's a lot of mitigation stuff around all this infrastructure, right? You might be able to mess up a server, but okay, then they'll just circuit break the connection that's causing issues because they don't care if it's a legitimate client because they have a million clients. So they can, if someone's misbehaving, they can just disconnect them, etc., etc.
Yeah, they can put CAPTCHA or something, right?
Yeah, also, there's a lot of mitigation strategies as well. But still, like, all in all, Google are not the only one running these with like Go servers. This affects everybody who's running Go. So this has a really wide impact. Google Pay, but this has a wide impact on every company that's using Go, which is basically every company that has backend these days.
I'd like to step back a little bit and take a little higher level question for a moment. So you spend a fair amount of time now looking at the HTTP2 RFCs. I'm assuming you're also very familiar with HTTP1. I'm curious, what from a security standpoint, how do you feel the two compare? I know HTTP2 is about better performance and so on, but from a security standpoint, is it better? Is it worse? Is it full of problems? Is it, just generally speaking, how do you feel about that?
Sure. Yeah. I mean, well, it's hard to say, to be honest. I mean, both of them are pretty complex, and always in complex, protocols or applications, there is a possibility to find some quite severe bugs. I think my problem with HTTP2 is that looking at these different implementations, right, when I was doing this in Q1, I sometimes realized that they were trying to kind of like copy paste a ton of like HTTP1 code to HTTP2, right? Personally, I think that this was the reason for continuation flat, because the processing, like in HTTP1, like there's like one, actually it's not thread, right? But for the discussion's sake, let's say there's one thread of parsing these headers, right? Whereas in HTTP2 implementations, there are 2 or 3, as I mentioned previously, right? Like reading a metaframe, reading into metaframe, then reading from metaframe, and then actually reading these headers, right? And I think that, maybe the programmers were like, okay, we need to put this limit somewhere, right? So let's put it there, but they forgot about it in the second place, right? So this is, I think, the problem. But I wouldn't say because of that HTTP2 is less secure, right? I think there probably will be bugs for HTTP2. They will be fixed. And yeah, I guess HTTP2 has these performance properties, as you mentioned, that eventually everyone will switch to HTTP2, right? But it's just a matter of time.
I wonder if my sort of gut feeling is that the spec is a lot more complicated. And I think you can even look at the RFC itself. It's longer, like it's way longer. It has much more features. So on the one end, maybe more features equals more bugs, equals more security problems. On the other hand, we learned so much from HTTP1, and this is a binary, overall, looking at this protocol, it looks like it had more thought put into it. So maybe less bugs because, we really advanced as a industry. It's very hard to know what will happen. But I definitely feel confident that people actually reading the RFC and then reading the implementation, there are 20 more people, or maybe it's you, Bartek, 20 times, but just people reading implementation of HTTP2, reading the RFC and going, wait, this is wrong. And finding, if not vulnerabilities, at least bugs, right?
Yeah, sure. And also to what you mentioned, actually, that's a valid point, right? Because you said like HTTP2 RFC is longer. And I kind of feels like actually HTTP2 in some way encapsulates entire HTTP1 inside itself, right? Because for example, because there are these data frames, right? For example, that actually sends actual request data, and all kind of bugs connected to HTTP1 data, like chunks. For example, if you check my blog, I also did some research connected to HTTP1 chunk encoding. Actually, very little amount of people know that there's like this chunk encoding of request bodies in HTTP 1 and also 2, I guess, where you you split a body into chunks. And there's like the first line of the chunk is like the number of bytes the chunk has, right? And then like in the new line, there's actually data connected to this chunk. But there's this very known feature called chunk extensions, which you can actually only learn if you read RFC or implementation of this in the code.
Mm-hmm.
And you can actually send like key value pairs, right, connected to this chunk, like metadata connected to this chunk or stuff like that. And actually it was possible in many servers, very similar to continuation flat, to send infinite number of bytes in these extension chunks, right? Chunk extensions. So it was actually possible to crash. Actually, this bug in Golang was all out of the memory crash, if I remember. Actually, maybe I'm wrong. So maybe scratch that. I don't remember very very well. But definitely Node.js, Rust implementations of HTTP protocol had all out of the memory crash. Right?
The surface level understanding of that is that even when the compiler runs for 15 hours to compile Rust code to find memory problems, it still can't overcome memory problems that come from very complex RFCs of networking issues. Even Rust compiler can save you from that. There's one thing I really noticed you said it a couple of times, and I want to circle back to it. You said you were lucky. You actually said it like twice or three times while we were talking. Oh, I was lucky to find this. I was lucky to find that. That's great. How do I, as a security researcher, let's say I read your blog post, I'm inspired, I want to also be a security researcher. How do I also make myself so lucky?
Yes, honestly, I don't remember saying lucky, but maybe I did, somehow. Yeah, actually, that's interesting because yesterday I saw this tweet that bug bounty is like 50% skill, 50% luck. And I think I kind of agree with that because, it really depends if you look at the, specific stuff. Okay, maybe there is some, unconscious process in my head saying me, okay, check this file, check the other file or stuff like that. But maybe that's actually skill. But I think you need a certain amount of luck. I guess in any industry you work on, right? You work in to be a little bit successful. And well, I guess I don't have a good answer for this, right?
So there's no go get lady luck that helps find the vulnerabilities.
Yeah, what I mean by that is like, okay, maybe I can talk about a little bit about my current research. So right now I'm trying to. Actually, there are like three parts of research I'm doing, but in Golang, I'm actually trying to understand how compiler works, right? And I got kind of like inspired to do that because of this XZ bug. You've probably heard about it, right?
Yeah, it was all over the news, but for listeners who haven't heard of it, we'll put a link in the show notes. But the short version of it is someone has been masquerading as a good open source contributor for 2 years and then added a really super complicated vulnerability hidden in test code and malformed files. It was very hard to see it. The human part of it is almost as interesting as the technical part, at least for me.
Yeah, so I can tell more about the details of this research later. But what I'm trying to say is that, the Go compiler has like hundreds of files. Sometimes these files have like thousands of lines. It's very like low level. It's really hard to understand. And at least me, for each research I kind of like come up with, I try to limit time. So because you can spend a year on one component, right? And still find nothing, right? So I try to limit like the research to a month or something like that, so that I don't kind of like dig into this too much. And I think I can define being lucky as like, there's like these hundreds of files and actually look at this one single file when there's something, right? It's interesting and can be, exploitable. So I guess, some people can tell it's luck. Some people can tell it's experience maybe, right? But I guess, you need a little bit of this to find these bugs, right? So.
That makes sense.
Yeah, and so quickly about this research. So, years ago, when I was actually still at Stellar.org, I found this bug in Go compiler because by accident, actually, because I was running, a code as a programmer, writing code as a programmer, and I was compiling it, but results of my code was different than I was expected. So obviously, I was like checking this for bugs in my code, but nothing made sense to me, right? And I shared my code with my teammates, and nobody was understanding why, right? So we're kind of like trying to make this code smaller and smaller to actually make find the smallest possible reproduction of this bug. And we submitted it to Golang. I can share a link later maybe, but basically the bug was that during compilation, Golang compiler actually makes a ton of optimizations, right? It removes that code. It removes the code that it feels it's unreachable, right? And I think this happened to my code, right? The compiler was thinking that, okay, this part of code should not be executed, but it actually was supposed to be executed, right? So I'm actually looking for something that, some kind of like supply chain, attack that's maybe possible for Golang, in which there is a public open source repository, right, written in Golang, and an attacker basically creates this PR with, valid looking code. But actually, Golang compiler optimizes it in a way that it actually changes the behavior, right? So I don't have anything right now to share because I found nothing yet, and maybe I will find nothing, right? But I was thinking that this is actually interesting, research, and maybe I should do that.
On the topic of how you do your research, I'm curious: do you use any tools? Are you just reading RFCs and code, or do you use like fuzzing, or do you use LLMs or other AI tools? What tools do you use on a daily basis to find this stuff?
Yeah, so that's a good question. So mostly, to be honest, I just read codes, and sometimes people like ask me like how does my work look like, right? And I'm saying like this is probably the boring type of job you would see.
You don't put on a hoodie and turn on the 3D terminal interfaces. I'm in, yeah.
No, unfortunately not. I mean, maybe like because I would call my job actually vulnerability researcher. It's not like a red teamer or something like that who has a bunch of tools that actually do something what you just said, right? Like they try to hack into systems using the already known vulnerabilities, right? I'm like actually doing this job that's actually used by them later. But yeah, I usually just read code. Sometimes I use LLMs really. As Jonathan mentioned, they are sometimes helpful for like small tasks. Sometimes I write tools. So actually, if you want, I can share like the other leg of my research. So actually, there were a ton of WordPress plugins bugs recently, right? So I also got interested into this because when I actually look at the write-ups of these bugs, they are mostly pretty simple. I mean, you can get RCE, which is like remote command execution, basically for free if you just find the specific plugin that's vulnerable. So for this research, I actually wrote a pretty primitive, like static analysis tool for PHP WordPress plugins, right? Mm-hmm. So what I did, I downloaded like top 200 plugins. I ran this tool, and it kind of like gave me interesting points, right, where I should actually look into to find something that can be a vulnerability, right? So yeah, tools are helpful. Fuzzing pretty little use to me, unfortunately. I mean, the problem with fuzzing is that usually the input is kind of like limited, right? Like the input that's generated by fuzzers, right? So I guess like bugs like continuation floods would be hard to find using fuzzers. Maybe I'm wrong. Maybe I don't know how they work that much, but I mean, fuzzers are really nice for parsers of certain formats, right? Like let's say there's this JPEG parser, right? And there's like, I create this base of tests, right? And I think it makes sense. But for like, RCE bugs, complicated DOS bugs, I don't think they are pretty useful. I can be wrong, but I can't find them useful.
So my first thought when you mentioned researching the compiler was like a mutation-based fuzzer that generates code, like valid code. instead of just inserting random characters. It can mutate based on adding code. But I don't actually know if it's a good idea. It just sounds really good in my head. It might suck.
Yeah, I guess it makes sense. The problem is that how the fuzzer know if the output is correct, right? That's a problem.
It can run go build, and because go build is so fast.
In my experience, very limited experience, fuzzers are great for finding bugs, but not per se security bugs. I mean, some of those bugs might have a security exploit underneath them. Like maybe you find where it handles input incorrectly. But I think I imagine that the security related bugs that a fuzzer would find would be so such a small fraction that it's kind of a needle in the haystack.
Yeah, I think, Jonathan, to what you said, I think it depends on the programming language used, right? Because I know that for programs written in C or C++, if you can crash the application, sometimes it's actually possible to exploit this,
true,
wrong memory address, something, buffer overflow, stuff like that, to actually gain some code execution privileges. But for Golang, not really, right? Mm-hmm. Probably the best thing you can find using fuzzer is a crash of the application, which is obviously a nice find, right? But not RC or something like that.
Or hidden features. Maybe it's an easier way to learn the RFC, just to fuzz the implementation instead of trying to read the damn document.
Bartek, it's been a pleasure talking to you and learning about security. If people are interested in reading more about this topic, I know you have a great blog. You want to talk about that? How frequently do you post? What kind of stuff do you write about?
Sure. So the blog post, my blog is maybe you can actually share a link because it's the domain is pretty complicated. I guess I need to find a new domain which is simpler to remember because this is my surname that info. But yeah, I don't post often. I just post when I have something really interesting and also public I can share. So yeah, please check it out. There's also an option to sign up for a newsletter if you want to be up to date. I only send messages when there's a new post and there's no other circumstances that will make me send an email. So no spam, promise.
And also, we missed it, but your email is at the bottom of the page. Like we said at the beginning
exactly.
of this episode. If you want Bartek's email, you can find it there. News to us.
Well, we like to round out each interview with a question. I think you've been prepped, so it shouldn't be too hard. When you were first learning Go, what surprised you the most, or what was the most challenging for you about the new language?
Yeah, that's a good question. So I really like. I mean, it was a good surprise, not a bad surprise actually for me. Go routines, right, were pretty nice. Like the way they work, how lightweight they are, right. It was pretty awesome. But also at the time, I was actually switching from Node.js, which was like the primary language at my company, right? I mean, at the company when I was, which I was part of back then. So type checking was a pain in the ass. But it's actually from the security perspective, it's very good to have a type checking, right? So
very good answer.
So thanks a lot, Bartek, for joining.
Yeah, thank you very much. Thanks for having me.
This has been super illuminating. I really recommend, if you listen to this and you found this interesting, go read the blog post itself. For me, it was, the technical details about the continuation flood was very, I want to say sort of inspiring, because it inspired me to I really like security. I want to do stuff because it's very simple to read. It's very easy to understand. And it makes me feel like I can do this thing as well. Like I can try to find vulnerabilities as well. I can't. But it makes me feel like I can, which is really, really great. So thanks a lot for joining.
Thanks for joining, and thanks for making our operating systems and our software more secure.
Okay, thank you very much. And again, thanks for inviting me. And thanks for Yanik, who reached out to my public email. You couldn't find.
Absolutely.
All right.
Thanks.